Hello everybody! Today we'll learn something about resistors. What is a resistor, how is it constructed, how it works, and also other useful information. Let's go straight into the action. A resistor is a passive component which absorbs the electrical energy and turns it into heat. It is a simple component that usually has two terminals, and it is very important because it can have multiple uses and we can find it in most electronic circuits. A resistor can be found in circuit schematic by one of the two standard symbols, one for the American standard and other for international standard. The parameter that characterizes the resistor is the electric resistance, noted with R and measured in ohms. The main function of a resistor is to oppose the flow of electric current. It limits the intensity of electrical current flow through it. Therefore, using a resistor can help controlling the value of electric current. Besides this main function, they can have many other secondary roles and can be used to reduce the voltage level, help filtering the noise of different frequencies, measure the current and voltage, set precise gain in precision circuits, and many more. What makes the resistor oppose the flow of electric current? Each resistor is made from different resistive elements that catch in their structure a part of the electrons from the electric current flow. Some electrons collide in the atoms of resistive materials and some escape and pass through it. The electrons that collide are transferring some of their energy into atomic vibrations, which are producing energy in heat form in the air molecules or heat sink device. The less electrons pass through the resistive material, the more it opposes the flow of electrical current and the value of resistance is higher. Let's look at the structure of the basic resistor. Resistive elements from resistors are the main elements in their construction. Such element consists in a conductor material that determines how many electrons, that is electrical current, can pass through it. It can be created from carbon films, metal oxides, metal foils, and others. It needs contact elements to connect the resistive elements with the terminals, and these contacts between them are usually made from nickel or palladium silver. Around the resistive element and contact elements, an isolating material is used to encapsulate them to isolate the conductive material, and is made from different resins, glass or ceramic materials. On top of all, a protection material is used to protect from various conditions the resistor and made usually from thermoresistant varnish. The terminals are the parts that are connected in the circuit. We can call them the legs of the resistor and are usually made from tinned copper with different diameters depending on the power needed to support. How do we choose the resistor that we need? Every resistor has a list of parameters that will lead to the right choice. Before the internet, these informations were only available in books, but now you can find all the relevant information with a single search for component datasheet. Datasheets are a way in which the suppliers present their goods, and they all have to present mainly the same type of information, so we can compare it, finding what is more suitable for the needs. This common information are the parameters that define the component. For resistors, some parameters to be taken in account from datasheets on a first look are nominal resistance, which is the value of the electrical resistance obtained in the manufacturing process. This value can have a tolerance due to the inaccuracy of the manufacturing process. A more precise value for resistors will require a more precise process and therefore a more expensive one. The tolerance can usually vary from 0.1% to 20%. Rated power will tell you how much power a resistor can withstand before getting destroyed. The power is measured in watts, and to keep it simple, it depends on the voltage and the current over the resistor. When the electrical current flows through the resistor, the energy from the moving charge that is blocked by the resistor is transferred in the body of the resistor in the form of heat. If the power will be big enough, the energy converted in heat might exceed the capacity of the resistor to dissipate the heat, therefore it will heat up to the point where it will get destroyed. Similar as the resistor can withstand a limited power, there is also a limited voltage, that is the rated voltage. Also, resistors have a temperature range in which they can operate, and if they exceed it, they will get damaged. If the temperature increases more than the rated temperature, then the power that the resistor can dissipate through heat will decrease. This phenomenon is known as derating and usually can be found under a graphic in the datasheet. Also, the resistance of resistors can modify with temperature. This parameter can be found as temperature coefficient of resistance. Generally, the electrical resistance increases with temperature. The hotter the material is, the more the material's atoms and molecules bounce in its structure, and it will be harder for the electrons to pass through the material. This is only something about resistors, and you'll sure find out more in the next videos. Until then, don't forget to subscribe, share and like this video, and we'll see you next time.